All right, this is Math 209, Week 4, Section 11.2. We're still going to be graphing, and we are still definitely going to be using Desmos. All right, so we are going to do this in a little bit of out of order here. So you've got this equation, x squared minus 6, and they want us to sketch it. They want us to identify the vertex. And of course we know it's a smiley face because the first number is positive here, and so it's going to be a smiley face, and the vertex will be at the bottom. In fact, we might as well sketch that, and the vertex will be at the bottom somewhere. And then we're supposed to compare this graph with what's called home base, or the mother function of y is equal to x squared. So let's do that first. So let's go down and do this. So I'm going to go to Desmos. And what I'm going to do is, what you'll notice here is x squared is in red. Here's the basic mother function. It's the home function. And then what happens when we stick on a little minus 6? Well, you'll notice the home function gets lowered by 6. Now, just to prove to you that it's the same function, I'm going to take it and I'm going to outline it here the best I can. All right. And now you'll notice when I take this, this is x squared, and when I lower it 6, I'm going to go down 6, and it matches up perfectly. All right. So what does that minus 6 do? It transforms the home function and it lowers it by 6. So that's what's going on. So the thing that you need to know is that minus 6 takes the home function and lowers it by 6. So what would happen if this was y is equal to x squared plus 4? Well, what would happen is our home function, instead of going right here, it would go up 4, and it would look like this. So that's the thing I want you to notice. So when we go over here, and we're supposed to compare, that's what it is. It's the y minus 6 is dropped by 6 compared to the, did I say y minus 6? I meant x squared minus 6. So the y is equal to x squared minus 6 is dropped compared to the y is equal to x squared. It's that minus 6 that does the dropping. Identify the vertex. Well, how do we identify the vertex? Well, if we're going to identify the vertex of this x squared minus 6, we can see that the vertex is right there. And we can see that the vertex is at negative 6, 0. We're done. If we weren't sure of it, if it looked like it was some sort of fraction, we would have to take our equation, which is x squared plus 0x minus 6. I had to put in that plus 0x because it's not showing up in the original equation, the original function. And this tells us that a is equal to 1, b is equal to 0, c is equal to negative 6. And now we're going to use that formula, x is equal to negative b over 2a, and we would continue doing our work, and we would figure out the x value, and we would figure out the y value, and that would give us our vertex. The x would give us the x value, the y work would give us the y value, and there is our vertex. But we can see our vertex right now. The vertex is very obvious. It's negative 6, 0. All right, so here we're going to sketch this equation, this 2x squared plus 3. So but I'm going to go out of order, and we're going to use Desmos, and we're going to compare it with the home function of y is equal to x squared. So I'm going to go over here, and here are our two functions. You'll notice the home function is in red. I think it's always going to be in red. And then you'll notice the transformed function here, the 2x squared minus 3. So let's first highlight the home function. So there is our home function. Now what happened? How does our home function compare to the new function, this guy? Well, that minus 3, we learned from a previous slide, that minus 3 drops the new function down by 3. And sure enough, you can see that. It used to be here, and then it dropped 1, 2, 3. It drops by 3, okay? But it no longer perfectly matches. It doesn't line up. You'll notice the blue, it doesn't line up anymore. That's because this 2 makes our new parabola compared to the home parabola. So here's the home parabola. And so the 2 makes our new parabola skinnier. And so this makes it skinny, and this drops it down, all right, compared to our mother or home function. I got to tell you, 8th graders love it when I say mother function. So anyway, this is a home function, and so it's been transformed. The minus 3 drops it down. The times 2 makes it skinny. So when we go over here, that's what you're going to talk about in section C. Identifying the vertex of our new function. Well, if we look at our new function and we zoom in, the vertex is right here, and we can clearly see that the vertex is negative 3. Oops, whoa, I did it backwards. The vertex is 0, negative 3, because it's at 0 on the x-axis, and then it goes down 3. So there is our vertex. So we don't need to use that fancy formula, although that fancy formula would work. X is equal to negative b over 2a. That would work, but we don't need it. Again, I'm going to go a little bit out of order. We're going to, first thing we're going to do is we're going to graph our transformation and our home function, and we're going to do those on Desmos. And when I go over here, here's our Desmos. Now you'll notice the red is our home function right here. That's x squared. Y is equal to x squared. And what happens with this x plus 3 quantity squared? Well, we see that our home function used to be right here. And I'm outlining it right there, if you were wondering. Okay, and so there is our home function, and then it looks like that plus 3 causes our graph to slide to the left. So that plus 3 causes our graph to slide 3 to the left, and that's kind of counterintuitive. When you think about plus 3, we often think that it should slide to the right, but that would be wrong. That plus 3 causes our home function to slide 3 places to the left. So let's go back to our home function. What if I had y is equal to x minus 2 squared? What would that mean? Well, that would mean our home function right here would slide 2 to the right. So it'd go 1, 2. And it'd be right there, and our vertex would be right there. All right, so it's kind of counterintuitive. Plus 3 slides it to the left, minus 2 slides it to the right. So going back here, now we need to identify the vertex of this new slid over equation, this parabola. We don't need the formula on this one because we can see that the vertex is right there, right here, and we can see that it's at negative 3, 0. It's been slid over to the left 3 spaces, so we don't need to use the formula. Right here, they're just kind of moving the question around a little bit. So here's our home function. Here's the new function that's been transformed. And it says to sketch, but we're going to sketch both of these using Desmos. And, all right, so again, our home function is right here in red. That's because it's over here. And then we have our new transformation down here. So what's going on? Well, let's do it in red, and let's highlight our home function. So here is our home function right there. Now our home function is right here, but you'll notice our new transformation is actually a downwards. It's a frowny face instead of a smiley face. So why is that? Well, it's because of that negative sign. So in a previous video, we knew that multiplying by 20 would make it skinny, but that negative sign makes it down, makes it go down. And so our original parabola actually is being transformed in that it's going to go frowny face because it's being multiplied by a negative, and then it's got to become really skinny, which I can't do. It's got to be really skinny because it's being multiplied by 20, as in negative 20. Negative makes it downwards, 20 makes it skinny. All right, and so that's how this compares to the original home or mother function. All right, so when we go back here, and what is the vertex of our new transformation, our new transformed parabola? Well, our vertex, we might have to zoom in, but we can see our vertex is right here at 0, 0. So we don't have to worry about any math. Although, if we wanted to, we could say that our equation is negative 20x squared plus 0x plus 0, and that tells us that A is negative 20, B is 0, and C is 0, and our equation would be x is negative b over 2a. But we don't need to do that because it's really obvious and we can clearly see that the vertex is 0, 0. So what we've got here is we've got our two functions. That's our transformation function, the one that's transformed, and here is our home function. So what we're going to do is we're going to graph them both on Desmos. Now when we do that, we get this beautiful graph right here. And we know that the red one is our home function because we can see it. It's right here. Y is equal to x squared. And I'm going to highlight that, and I'll highlight it in red. And so here is our home function. All right. And so you can see it. It's right here. Now, what happens? How did it transform from here to here? What did it do? Well, if we, and I'm gonna let's see, I'm gonna put our vertex on that home function as well. So there. And let's see if it's still connected. Nope, it's not connected, so I got to fix that. So I'm going to connect these two guys and group them. So, all right, so now, good, there we go. So if we look, we can see that the vertex, the home function here, kind of moved from here down to here. So how did our vertex change? Well, we know that this minus 3 caused it to drop 3, because we've learned that from an earlier slide. And then what does the plus 4 do? It causes it to move to the left 4. So the minus 3 causes it to drop 3, and then the plus 4 causes it to move to the 4 to the left. All right, so that's how it gets, that's how it gets transformed. All right, and so let's write that down. So let's get some thin pen here. So the plus 4, move left. The minus 3, move down. and that's how it's transformed. All right, so if I were to put this here, and if we were to have a different equation, let's say y is equal to x minus 2 squared plus 5, what would that do? Well, what does the minus 2 say? Well, the minus 2 says go to the right, slide it to the right. And what does the plus 5 mean? Slide it up. So if I wanted to graph this equation, I would take my home equation and I would slide it two spaces to the right and 5 spaces up, and we would get this new equation way up here. So that's the idea, is we are supposed to be recognizing how these numbers transform the home function into something different. And let's see, did I answer that whole question? Yeah, now if we wanted to, the way we would, we need to identify the vertex. So let's identify that vertex. So the vertex is of this equation right here, that we want to know the vertex. So we're going to have to zoom in, and we can see that the vertex is pretty obvious. It's right there, and it's at -4, -3. And how do we know that? Because we took the original vertex and we slid it 4 to the left and 3 down. So that puts it at -4, -3. So we don't have to use the formula if we're going to be finding the vertex. We don't have to use the formula. We could just inspect it and see it. In fact, it tells us right up here, slide to the left 4 and go down 3. All right, so we have two functions. We have this home transformed function right here, and then we have the home function right here. So what we're going to do is we're going to go over here and we're going to graph it in Desmos. So there we go. And you can see that we have our red function is the home function because it says so right here. And if we were to trace that, let's trace it. So that's going to look like this, and it's going to go down, and then it's going to go up. And the vertex we can see is right there. And so here's our home function. And then the new function gets transformed down to here. So what happened? Well, it slid 3 spaces, 1, 2, 3 spaces to the left, and then it went 3 spaces down, all right, to right there. So what part of that? Well, what part of the equation did that? So this goes move left. This says move down. And what does the 2 do? What does that 2 do? So when we look, here's the original parabola that got shifted around. It used to be here, it got moved over to the left and moved down. So the other thing is we notice that our new parabola, the transformed parabola, is skinny. So that 2 makes it skinny. Makes it skinny. And because it's skinny and up, because it's a positive 2. Because it's a positive 2, it's going to be skinny and up. If it was a negative 2, it would be skinny and down, like a frowny face. All right? So that is our transformation. If we want to identify our vertex, well, that's easy. Because our home function was at 0, 0. Our vertex was at 0, 0, but it got slid to the left 3 and down 3, so our new vertex is at -3, -3, -3. So that's our vertex. We don't even have to do any math. We just use logic. All right, last one. Here's our home function. Here's our transformed function. We're going to graph both of those on Desmos, and when we do that, we see here's our home function, here's our new function. This is the transformed function right here. And let's highlight our home function. We'll do that in red. So when I highlight our home function and notate where its vertex is, there we go. And then I'm going to take that, and so what's going on? So when we take our home function, what happened? It got turned around and got moved to here. So what happened? Well, it slid to the left 3. And we know that because we've learned that this says move left. And then what else did it do? It dropped down 3. And that's because of this. Move down. All right. So then what happened? What else happened here? Well, our original function was up here, but it also got down. It went downward. So we're going to zoom in. So that minus says it's a frown. And what does the 1/3 do? Well, the 1/3 makes it wider instead of skinnier. Makes it wider because look, we can see that the original one was right here, but the new transformation is wider. So there we go. So the things that we're supposed to learn, when you look at a new transformation, you're supposed to be able to see the +3 moves it to the left. The -3 moves it down. The negative makes it a frown as opposed to a smiley face. And the 1/3 makes it wider. If this was like a 5, it would make it skinnier. So fractions make it wider. Numbers make it fatter. No, I'm sorry, I said it wrong. Fractions make it wider or fatter, and a number like 5 or something makes it skinnier. All right, and so we also need to know what is our vertex. Well, it used to be 0, 0, but it got moved 3 to the left and it got moved 3 down. So the vertex is still -3, is now -3, -3. It's been that way on the last few problems. All right, and that wraps up this video.